Let's talk about something that sounds like it's straight out of science fiction, but it's happening right now. We're going to dive into how we can take old, everyday drugs and, by pairing them with some seriously futuristic science, turn them into brand new, powerful weapons against disease.
I mean, just think about that for a second. What if the answer to a really tough illness isn't some brand new molecule we have yet to discover, but it's actually hiding in plain sight, in a medicine we've known about for decades?
Well, there's actually a name for this whole idea. It's called drug repurposing. It's this brilliant strategy of looking at drugs we already know are safe and finding totally new jobs for them to do. And believe me, this concept is completely changing the game.
So, how does this medical hack actually work? Let's get into it.
Honestly, the core idea is that simple. You take a medicine we already trust, one that's been used for years, and scientists discover it has a hidden talent for fighting a completely different disease.
Now, this is where it gets really clever. Developing a drug from scratch, that gray line you see, can take over a decade and cost billions of dollars. But with repurposing, we get to take a massive shortcut. Since we already know the drug is safe for humans, we can skip a lot of that early, super expensive testing. This isn't just a small-time thing either. This strategy accounts for about 30% of all recent FDA drug approvals. It's a huge deal.
Okay, so it sounds like a perfect system, right? Well, not quite. Just because a drug looks promising in a lab test doesn't mean it's ready for prime time. There's some major hurdles to overcome.
And here's the problem. A drug might have been designed perfectly for its original purpose, but that same design can be totally wrong for its new mission. This is where a fantastic idea can smack right into a biological wall. Let me show you what I mean. First up, poor solubility. Take albendazole. It's an anti-parasite drug that shows amazing potential for fighting cancer. The catch? It's basically like trying to dissolve a rock in water. It just doesn't get into the bloodstream well enough to ever reach the tumor.
Then you've got poor absorption. Metformin is a super common diabetes drug that might also protect our brains and fight cancer. The problem here is our gut is just not very good at absorbing it. So a lot of the drug's potential is wasted because it can't get where it needs to go.
And number 3, and this is a big one, high toxicity. Sometimes, for a drug to work on a new disease, you need a much higher dose. Hydroxychloroquine, for example, was looked at for viruses, but the dose needed to be effective got dangerously close to levels that are toxic for the body, and that's a risk you just can't take. So, you've got these amazing drugs that are stuck behind these biological walls. How in the world do you break through? The answer is just incredibly cool. Nanotechnology.
With nanotechnology, we can build things on a scale that's almost too small to imagine. We're talking about creating these things called nanocarriers. I want you to think of them as microscopic, programmable delivery drones, custom-built to carry a drug payload exactly where it needs to go.
And get this, these little nanodrones are specifically designed to solve the 3 big problems we just talked about. They fix solubility, they allow for pinpoint targeting, and they can control exactly when and where the drug is released. It's a total game changer. So, check this out. For that solubility problem, you take a drug like albendazole, it hates water, and you tuck it safely inside one of these nanocarriers, kind of like a tiny little transport pod. Suddenly, the drug can travel through the bloodstream, no problem at all.
Okay, so what about hitting the right target? This is where it gets really smart. We can attach special molecules to the outside of the nanocarrier that act like a key. This key only fits the lock on a specific cell, like a cancer cell. That means our little delivery drone flies right past all the healthy cells and only unloads its cargo at the disease site. That means fewer side effects. It's brilliant.
And for the final trick, controlled release. These nanocarriers aren't just dumb boxes, they're smart. We can design them to pop open and release the drug only when they sense a specific trigger, like the acidic environment inside a tumor. It's the ultimate in precision medicine.
All right, this all sounds amazing in theory, right? But does it actually work in the real world with real patients? Oh, absolutely. Let me show you a landmark example. Let me introduce you to doxorubicin. It is a beast of a chemotherapy drug, incredibly effective at killing cancer, but it had a devastating side effect. It could cause severe, permanent damage to the heart. So the challenge was clear. How do you use this weapon without destroying the patient in the process? The solution? Put it inside a nanocarrier. And this is the result. Doxil. By wrapping doxorubicin in a protective nanobubble, scientists created a revolutionary new treatment. In fact, Doxil was so groundbreaking it became the very first FDA-approved nanomedicine way back in 1995. This proved the whole concept could actually save lives.
So what did it do? The results were just staggering. The new nano formulation led to an 80% reduction in heart toxicity. That's not just an improvement, that's a whole new level of safety for patients.
But here's the kicker. It wasn't just safer, it was also more effective. Doxul was able to deliver a 6 times higher concentration of the drug directly into the tumors. So you get less harm to the body and more firepower against the cancer. That is the incredible power of this technology. The success of Doxul wasn't just a one-hit wonder. It fundamentally wrote a new playbook for medicine. It showed that this combination of old drugs and new delivery tech has a massive future ahead of it.
And if we zoom out and look at the big picture, the results are just undeniable. Across the board, about 80% of these reformulated drugs show way better bioavailability, meaning more of the drug actually gets into your system to work. And at the same time, the damage to the rest of the body plummets, dropping by an incredible 40 to 90%. The drugs become both stronger and safer.
Which brings us right back to where we started. When you think about all the thousands of approved drugs sitting on our pharmacy shelves right now, you just have to wonder, right? How many more incredible, life-saving cures are just sitting there waiting to be unlocked, hiding in plain sight, just one clever nano solution away from changing the world?